In this video, we are going to discuss single particle motion in plasma. Okay, so here you see, we know that a system of plasma, it contains positive and negative charged particles, positively and negatively charged particles. Okay, and due to the motion of these charged particles, there must be a flow of current, and due to the current, and magnetic field should be there, and also due to the charge there must be electric field. Okay, due to charge there must be electric field. So here we are going to study the behavior of these charged particles when an external magnetic field and electric field is being applied. Okay, but in plasma it is very difficult to study the behavior of these particles. That's why we are going to take a single particle motion in plasma. Okay, so we will study the motion of single particle in plasma. Okay, so here you see, in the first case we will consider only uniform magnetic field and no electric field is applied. Okay, uniform magnetic field. Uniform magnetic field B. Okay, and no external electric field. That is E is equal to 0. Okay, so let us consider this. So we have considered the magnetic field, uniform magnetic field B is being applied along Z axis. So B Z cap. Okay, so suppose this is the X, this is Y axis, and this is the Z axis, which is coming out of the screen. Okay, so whatever the doesn't matter what device you are using, it may be mobile or laptop, it is the direction of the magnetic field we have taken here along Z axis. That means it is coming out of the screen. Okay, imagine like that. Okay, so here is the positive charge and it is moving with velocity v, suppose. Okay, now, and this is the direction of magnetic field. Okay, in order to know the force act on this charged particle due to the magnetic field, that means the Lorentz force. So what do you mean by Lorentz force? So when suppose when when a charged particle moves in a magnetic field and electric field, the net force acting on it due to the force, net force acting on it is equal to the sum of the force due to magnetic field and force due to electric field, that is Lorentz force. But here electric field is not applied, so that's why the force due to magnetic field is the Lorentz force. Okay, how to determine the direction of that force? Okay, now you see, we can determine the direction of this force by using Fleming's left hand rule. Okay, if it is positive charge, if a positive charge is moving in this direction, velocity is in direction, then we can consider this is the direction of current. If it is negative, then we have to take the opposite direction of motion. Okay, so then, and you see, magnetic field, direction of the magnetic field is coming out of the screen. So stretch the three fingers, thumb and index finger and the middle finger. Okay, mutually perpendicular. Okay, stretch the three fingers, thumb, index finger and the middle finger of your left hand. Okay, then the direction of the current will be shown by the middle finger, and the direction of the magnetic field should be pointed towards the index finger will be pointed towards the magnetic field. Then the thumb will point downwards. That means this is the direction of the force. Due to this downward force, instead of going straight, this charge will move like this. Okay, in this position, at this position, the velocity will be in this direction, the motion is in this direction, and in this situation the magnetic field is again in the same direction, outward direction. This is coming out of the screen, and the force will act in this direction now, and then it will take this part. Okay, so that's how it will take a circular path. Okay, and there must be a center if it is circular path, which is known as guiding center. Guiding center. Okay, so we can determine this direction of the force acting on this charged particle using the Fleming's left hand rule. Okay, so hope you have understood this. Now let us calculate the Lorentz force. Okay, so we know that Lorentz force F vector is given by Q into V vector, that is velocity, cross vector B, that is magnetic field. Okay, so we also know that F is equal to ma. Okay, a can be written as v dot. Okay, differentiation of v with respect to time t. Okay, that is what v dot. Okay, so combining these two equations, from these two equations we can write that m v dot is equal to q into v cross b. We can write this. Okay, so now you know how to determine v cross b. So this is x component, y component, and z component. So vx, vy, vz are the three components of velocity v, and as the magnetic field is being applied in the direction along z axis only, it's coming out of the screen. Okay, so only at z we will get b. Okay, along z only we will get b, and in other components will be 0. Okay, the other components will be 0. Okay, so then now calculate v cross b here. That will be equal to x cap, then vy into b, minus 0 into vz is 0. Okay, then minus y cap, then y cap, vx into b. Now let us take vx into b minus 0 into vz, that will be again 0. Then z cap, so let us take this part, v into 0 into y dot, that means we will get 0, z dot 0. So here you see, now we can write the left hand side like this: m vx dot x cap plus vy dot y cap plus vz dot z cap is equal to, then this is the left hand side, so right hand side can be written as q into x cap vy b minus 0, again vy b. Okay, then minus y cap, that's going to be equal to vx b only, then plus z cap into 0. So that is what we have got now. So now let me clean this part, sorry. Okay, so now what we can do is we are going to now find the three components of v. Okay, so now let me obtain the three components. M vx dot will be equal to, if you compare the x components, then you will get q vy b. Okay, that implies vx dot is equal to q by m vy b. This is equation number 1. And y component will be m vy dot. If you compare the y components, okay, these are y components, then you will get m vy dot is equal to minus q vx b, which implies vy dot is equal to minus q by m vxb. This is suppose equation number 2. And the z component, if you compare the z components, this is vz and here z cap 0, then you will get that vz dot is equal to 0. That means, which implies vz must be constant, because differentiation of vz with respect to time t is 0. That means vz is constant. So differentiation, that means d dt of vz is the v dot, isn't it? If it is equal to 0, then v must be constant. Okay, hope you have understood this. So now let me write these two equations at the top of the page. Okay, I am going to clean this page now. Okay, so let me write the equations there. This is equation number 1. So here it is 1, and this is the equation number 2. This is the equation number 2. Okay, so let me write like this. This is equation number 2. Okay, so now what we're going to do, let us differentiate equation number 1. Differentiating equation number 1 with respect to time t, we have, so what we have, we will get that v double dot x. If you differentiate this equation, then you will get v double dot x is equal to q by m vy dot b. Okay, now you see, you can replace the vy dot by this equation number 2, by the right hand side. You can replace this vy dot by the right hand side of equation number 2. So let's do that. So if you replace this, then what you will get, q by m minus q by m vxb into b. So using equation number 2, then we will get vx double dot, just keep it like this. Okay, then we will get minus qb by m whole square into vx. We will get this is equation number, suppose 3. This is equation number 3. So that's what we have got. Okay, now this is vx double dot. Okay, you can write like this. This is equation number 3. Now again, differentiating equation number 2 with respect to time t. Differentiating equation number 2 with respect to time t, we have, so what we have, so we will get vy double dot is equal to minus q by m vx dot b. Okay, now you can replace the vx by this part. Sorry, not this one. Here you can replace the vx by this right hand side of equation number 1. Okay, so let us replace this. Okay, doing so, we will get minus qb by m whole square into vy. This is equation number 4. Okay, let me use another ink here. Let me use black color. Minus qb by m whole square vy. Okay, this is equation number 4. Now you see, the equation number 3 and equation number 4 are in the form of simple harmonic motion. Okay, so that is what simple harmonic motion form is. V double dot is equal to minus omega c square into V. Yes, so this is the form of simple harmonic motion. If you compare this equation with those two, equation number 3 and 4, then we will get that omega c will be equal to plus minus qb by m. Okay, I am writing here plus minus because q may be positive, q may be negative, and this frequency is known as cyclotron frequency. This is cyclotron frequency. Okay, so these are in the form of simple harmonic motion equation. Okay, so comparing with that, we will get WC, that is cyclotron frequency, equal to plus minus q by v. Okay, so now I have to keep the equation number 3 and 4 only, then I have to erase the remaining part. Okay, so let me take the equation number, let me clean this part. So let us take this equation number 3 here. This is equation number 3 and this is equation number 4. Let me keep these two equations here and this frequency also. Okay, so let me make these things a little bit smaller. Okay, so I have taken only 3 and 4. Okay, now clean these parts. Okay, so if you want to note, then you can pause the video and you can note it. Okay, so now as these equations are in the form of equation of motion of simple harmonic motion, so we can assume their solutions like this. Let the solution of equation number 3, suppose equation number 3, we can take Vx is equal to V perpendicular e to the power I omega c t. Okay, this is equation number 5. So here V perpendicular is the maximum velocity in the plane perpendicular to B. Okay, so V perpendicular is the maximum velocity in the plane perpendicular to magnetic field B. Okay, so here you see from equation number 4. So from equation number 4, so what we're gonna have, Vy is equal to m by qb into Vx dot. Okay, so from equation number 4 we will get Vy equal to so here you see, if you simplify this part from equation number 4, so let me show you, minus q by m Vx dot b is equal to minus q b by m whole square Vy dot. So here you see q minus minus cancel here, q by m into b cancel with square, so we will have v dot x is equal to q b by m v y, and that implies vy is equal to m by q b v x dot. Okay, so here you see wc is equal to qb by m, so m by qb we can write 1 by wc. Okay, so that's how we can write. So let me clean this. That's why we can write vy is equal to v dot x by wc, here plus minus. Okay, this is one thing. Then again from this equation number 5, okay, what we can write? If you differentiate equation number 5, so differentiating equation number 5, we will get vx dot is equal to v perpendicular I omega c e to the power I omega c t. That's what we will get. Okay, that is vx dot. Now use this value here in this equation, then we will get vy plus minus 1 by wc v perpendicular, sorry, not wc, omega c, sorry, omega c I omega c e to the power I omega c t. Okay, that's what we will get. Then omega c cancel, so this results turning out to be vy plus minus I v perpendicular e to the power I omega c t. This is equation number 6. Okay, so now we have got equation number 6. So now let us keep the equation number 3, equation number 4 and equation number 5 and 6 on this page. So I think you should note up to this part, then I will erase the remaining part other than the equation number 3 and 6, 3, 4, 6 and 5. Okay, I will keep the equations only which are required. Okay, then I will clean the remaining parts. So hope you will pause the video and note these things. Okay, now from this equation number 5, you see vx can be written as dx by dt. Okay, this is from equation number 5. Okay, so dx by dt is equal to, we can write v perpendicular e to the power I omega c t. Okay, now let us integrate both sides from x naught to x. So dx we can write like this, v perpendicular e to the power I omega c t, and let us write the dt on this side. Okay, so integrating this we will get x minus x naught is equal to v perpendicular e to the power I omega ct divided by I omega c. Now multiplying I with both the numerator and denominator, it becomes x minus x naught is equal to minus I v perpendicular by omega c into e to the power I omega c t. Okay, this is equation number 7. Okay, so what we have done here, so we have multiplied I with both numerator and denominator. Okay, so we have multiplied I with both the numerator and denominator here, then we have got this. Okay, equation number 7. Okay, so hope you have understood this. So now again from equation number 6, okay, from equation number 6, so what we're gonna have from equation number 6, okay, we can write Vy as dy by dt which is equal to V perpendicular e to the power I omega c t. Okay, that implies dy V perpendicular e to the power I omega c t into dt. Okay, that's what we have got. Oh, sorry, one more thing, there should be I think plus minus IVB. So we are taking the equation number 6, isn't it? So from here we have to write here there is plus minus, so I have made the plus minus here, and there should be I before V perpendicular. Okay, so let me write it properly. Okay, okay, now if we integrate both sides from y naught to y, then what we will get, y minus y naught is equal to plus minus V perpendicular by omega c e to the power I omega c t. Okay, so that's what we will get, and this is suppose equation number, this is equation number suppose 8. Okay, so let me, so this is the equation number 8 we have got here. So now I will keep the equation number 7 and equation number 8. Okay, so you can note it up to this stage. So because I will keep the 7 and 8 only now. Okay, I will clean the page. Okay, this is equation number 7, let me keep it here, and this is 8. Okay, this is equation number 8, let me write here. Okay, so these are the two equations 7 and 8. Okay, now what we are going to do, now you see, we know the equation of a circle. Suppose this is the x-axis, this is y-axis. If the center is here, if the center is here, this is a circle, and there is a point x comma y on the circle, x comma y, and then its equation, if r is the radius, then its equation is given by x square plus y square is equal to r square. Okay, if the center is at the origin. Okay, if it is not at the origin, it's somewhere, suppose this is the point, is this, it is the center, suppose x naught y naught. Okay, and there is a circle this, and here is a point x comma y, then equation of this circle is given by what, x minus x naught whole square plus y minus y naught whole square is equal to r square if the radius is r. Okay, so this is the equation of a circle. So here in this case, okay, in this case, so let me minimize this. Okay, instead of r we will use rl square, instead of capital R we will use here rl square. This is called Larmor radius. Okay, this is Larmor radius. Now let us obtain RL. So RL square will be equal to square of this plus square of this, but we will take the only real parts here. Here you see e to the power I omega c t. Okay, that's going to be equal to cos omega c t plus I sin omega c t. Okay, so if you take the real parts, okay, if you put this value here, and if you take the real parts, okay, then we will get So what will be the real parts of from these two equations we will get? Then from equation number 7, okay, from equation number 7 what we will get, x minus x naught is equal to minus I v perpendicular omega c e to the power I omega ct is equal to cos omega ct plus I sin omega ct. Okay, if you multiply this with this, then you will get minus I v perpendicular omega c into cos omega ct minus I square, which becomes minus 1. Okay, I square is equal to minus 1. So here it is minus 1. Then v perpendicular by omega c into sine omega ct. So this minus 1 and it is minus, so it will be plus. So you can write this is plus. So this is the real part here. Okay, so from 7 we have got the real part x minus x naught. Here we have to take the real part only, because you see this left hand side is real, there is no imaginary part, so we have to take the real part only. Okay, this one. So this is what we have got from 7, x minus x naught. Okay, so then, so what we will get from the equation number 8. Okay, equation number 8. So from here we will obtain y minus y naught. Okay, so if you put this value here, then you will get plus minus omega v perpendicular by omega c into cos omega ct plus I sin omega ct. Okay, then if you multiply here, this is going to give you plus minus v perpendicular by omega into cos omega ct, and in the next part you will get I into I plus minus I v perpendicular omega c sin omega ct. So this part is imaginary as there is I. Okay, and here is the real part only, this part is the real part. Okay, so y minus y naught we will get plus minus v perpendicular by omega cos omega ct. Okay, that's what we have got. Now using this, so let me clean this a bit. Okay, using these two values of x minus x naught and y minus y naught here in this equation, so we will get rl square is equal to v perpendicular by omega c sin omega ct square plus v perpendicular omega c cos omega ct whole square. Okay, on squaring this minus will be plus, that's, and this is gonna be equal to v perpendicular by omega c whole square into, we can write sin square omega ct plus cos square omega ct, and sin square omega ct plus cos omega ct will be 1. So definitely, so we will get rl square is equal to v perpendicular by omega c whole square. That means rl will be equal to v perpendicular by omega c. Okay, v perpendicular by omega c. We know omega c is equal to qb by m. That's why if you put the value here, then you will get rl is equal to m v perpendicular by qb. Okay, qb, let me write it properly. So this is the value of rl, expression for rl. Okay, and this is known as Larmor radius. Okay, and taking the real parts only, equation number 7 becomes x minus x naught equal to RL. Okay, RL, we have used this Larmor radius in this equation number 7 and 8. Okay, sine omega ct, and equation number 8 reduced to y minus, sorry, it becomes y minus y naught plus minus RL cos omega ct. Okay, now you see, this is the positive charge moving in this direction with velocity v, and here you see, and the direction of the magnetic field, this is coming outward, coming out of the screen, if you imagine like this. Okay, then it moves like this in this circular path. Okay, this is the direction of motion when the magnetic field, applied magnetic field, external magnetic field that we have applied, it is coming outward. Okay, along that direction. Okay, it is coming out of the screen, and due to the motion of this surge particle, okay, there must be this magnetic field which is coming out of the screen that we have applied along z axis, that is applied by us, that is external magnetic field, and one magnetic field will be generated due to the motion of this surge particle, and that will be in the opposite direction of this external magnetic field. Okay, that will be in the opposite direction of the external magnetic field. Okay, so if it is moving in this direction, then this is the positive charge. Then how to determine the magnetic field due to this charged particle? In order to determine this, you need to use the right hand thumb rule. Okay, so if you consider that you are if you curl your fingers other than the thumb, if you curl your remaining fingers in the direction of the motion of this charged particle, in which direction it is moving, okay, then the thumb will point it towards this direction, which is the magnetic field due to this charged particle. Okay, so therefore we can write the magnetic field due to the charged particle is opposite to the external magnetic field. So hope you have understood this topic. Okay.